Okay, I'm going to look at polynomials. Now you have all my notes, but I just want to go through it just to make sure you understand where I got the things from. So if we look at example 1 here, let's take 3 each of these. So this is just adding and subtracting. It's dead easy. So for example 1, I have got fx equals 2x cubed minus 3x squared add 1. And I get gx equaling x cubed add x squared minus 3x minus 4. First question just wants me to add them. So just add the x cubes together. So 3x cubed. Add the x squared, so minus 3x, add 1x is minus 2x squared. Add the x's, so it's just minus 3x. And then add the numbers. 1 minus 4 is minus 3. Now, the next one, part 2 there, is just subtracting them. So again, straightforward enough. I would advise writing it out again when you're subtracting them. So 2x cubed minus 3x squared add 1. Subtract the gx, which is x cubed plus x squared minus 3x minus 4. And just do it the same. X cubes first. 2x cubed minus 1x cubed is 1x cubed. Minus 3x squared minus x squared is minus 4x squared. Look for the x's now. Minus minus plus 3x and 1 plus 4, 5. So that's all there was in that first wee section there. The next wee section is multiplying polynomials. So if you look at my notes, you will just see me do the 2 examples. So I'll just run through that with you now, just to check that you're happy enough with it. So example 2, multiply x squared plus 3x minus 2 by 2x squared minus x plus 4. Notice why I put brackets around it, because there's more than one term. Just take your x squared through. 2x4 minus x3 plus 4x squared. Now take your 3x through. So sign, number, letters. And again, sign, number, letters. And again, sign, number, letters. And then I've got to take the minus 2 through. So don't forget to take that through. So minus 4x plus 2x minus 8. And just tidy it up. So do the x4s first. That's done. Then do the x3s. Minus 1 add 6 is 5. So plus 5x3. Now do the x squareds. 4 take away 3 is 1. So plus x squared. And then do the x's. So 8. I'm just noticing here there should be another. This doesn't look right. Let me double check. Where did that come from? So I think there's too many x's here, you see. That's my issue. So let's go back and see. Minus 4x squared. There it is. Okay, so you notice if you make a mistake, you'll simply be able to fix it up later on. So I'll just pop it in there and fix it later. So 12x plus 2 is 14x and minus 8. So 2x4 add 5x3 minus 3x squared plus 14x minus 8. Example 3, let's have a look and see what example 3 is. So if I scroll down, oh, it's there, 3 brackets. So I'll just write that out and just run through how I did that. X minus 2, 2x add 3, 3x minus 1. It doesn't matter which brackets you start with first. I'll start with these 2. 6x squared minus 2x plus 9x minus 3. And tidy that up. X minus 2, 6x squared add 7x minus 3. And now I'm just going to multiply through by the x. 6x cubed plus 7x squared minus 3x. Multiply through by the minus 2. Minus 12x squared minus 14x plus 6. And just tidying that up. 6x3, 7 take away 12 is minus 5x squared. Minus 3 take away 14 is minus 17x plus 6. Now, the next wee section here in the notes, just sort of doing both of them together. You have both of these attached anyway. How to cut a long story short here, a quadratic has got an x squared power. And this is the graph, sorry. Happy and negative is sad. A cubic has got two turning points. This is called the maximum turning point, and it's called the minimum one. That's a positive cubic. A negative cubic will go the other direction. So that's a turning point, and that's a turning point. Sometimes in cubics, both of these turning points come so close together that they actually meet. So the max and min points are combined, and this is called a point of inflection. Now, a new one, a quadratic graph. It's got three turning points, 1, 2, 3, and that's a positive one. Negative one's just upside down. Now, whenever these 3 points join together, it's like a wide bottom. Okay, so it's a bit wider than an x squared graph. So that's all you need to know in there, just the basic forms of those graphs. So if I scroll the whole way down, and we're on to sketching graphs now, if I can find an example here. Right, here's the first example. So I'm just going to take you through how you do that. I'll just set these notes aside and give myself a new page so you can see me building it up. So I'm trying to do y equals x minus 1, x add 3, 2x add 1. It crosses the x-axis when y is 0. So that means each of those brackets equals 0, because they all multiply together to give the y, which we are now saying is 0. So this one crosses at x is 1, this one crosses at minus 3, and this one crosses at minus a half. So 1 minus 3 minus a half. I always like to find, it's easy enough to do, see when it crosses the y-axis. It's good practice. So cross the y-axis when x is naught. So y equals naught take away 1, naught add 3, naught add 1. So y equals minus 3. So I've got a picture of what's going on. If you look here, x, and 2x, they're multiply out to give you 2x cubed. So it's going to be a positive cubic graph. So it starts low and it goes up and down and up. And that's all you need. The next graph in your notes I'm going to take you through is this one here. Y equals x, x minus 2 squared, x add 2. Now I want you to pay particular attention to this one because something different happens. As normal, it crosses the x-axis when y is 0. So you put each of these bits equal to 0. So x equals naught, x minus 2 squared equals naught, so x equals 2, and x plus 2 equals naught, so x equals minus 2. Now, this one here is one I'm interested in because it came from a squared term. Plot it on. Naught, 2, put a wee star there, and minus 2. X squared, and x all together gives me a quadratic, x to the 4. So it's one of those shapes. Now, if you notice I put a wee star here, I go through here, I go up through here. When I have the wee star, I bounce off the axis. That's called a repeater root. You're bouncing off that axis there. If you ever see that. So, yeah, that's that wee bit done. And the next wee bit is find a polynomial, yes, which has roots. These are awkward wee ones, but I'll take you through how you do it. So you've got an example 5. The roots x equals 1, x equals minus 3, and x equals 0.5. I'm going to work backwards. I could say that as x minus 1 equals 0. I could say that as x plus 3 equals 0. You know, just bringing the numbers on the other side. I can put brackets in those. If I combine all of those, just working backwards, I'm getting this expression. I'm going to multiply this one out. So times through that first bracket. So x minus 1, x squared, add 1.5x minus 1.5. Tidies that up. Sorry, that's 2.5, of course. Now I'm going to multiply through by the x. So x cubed, add 2.5x squared, minus 1.5x, multiplying through by minus 1. 0.5x plus 1.5. And tidying that up, I get x cubed. 2.5x squared minus x squared is 1.5x squared. Minus 1.5x, take away 2.5 is minus 4x, add 1.5. Now, so I've done that. I'm just going to look back at the question. And it's just saying, find a polynomial that has those roots. So, yeah, that's me finished. And in effect, I could actually have any factor of that. So if you multiplied everything by 2, it would still be a polynomial which has those roots. If you multiplied it by 4, it's still a polynomial that has those roots.